Hello, sir. Our group is from group CE2 and will be presenting about the topic of nozzle. So this is our group member, and I would like to invite Imran to discuss about schematic diagram.
Okay, this is the schematic diagram of the nozzle. There are three different types of nozzles here. First one is the convergent nozzle, the second one is the divergent nozzle, and the last one is the Laval nozzle.
Now, I'm going to explain about the function of the nozzle. So first thing first is it's to increase the velocity of the fluid at the expense of pressure. Next, it's to convert pressure energy and thermal energy into kinetic energy, and lastly, to direct fluid jet into a specific angle, or it is called as nozzle angle. Next.
Okay, these are some applications that we use for nozzles. So, firstly, we used nozzles in steam turbines, gas turbines, water turbines, and jet engine. Next, we also use nozzles for flow measurements, for example, the venturimeter. Thirdly, we use nozzles to remove air from a condenser. Fourth, we use nozzles to make an artificial fountain. And finally, we use nozzles as injectors in boiler. Okay, so the first picture over here, it's a water hose. The second picture is a venturimeter. A venturimeter is used to measure the flow rates of fluids inside a pipe. The third picture is a pressure hose nozzle. The fourth picture is a steam turbine. The fifth picture is a jet engine. And last but not least, the last picture is an artificial fountain nozzle. And I'll pass it to the next presenter.
Okay, for the tutorial question, the question asks for the mass flow rate of the steam. From table A6, we can get the specific volume of the pressure and the temperature given, which is 4 megapascal and 400 degrees Celsius. From the formula that we can get from the slide, we substitute the value and get the answer of 4.086 kilogram per second. Next, I pass it to Ainur.
For the second question, which is to find the exit velocity by using the energy balance, E in minus E out equal to delta E system, which is equal to 0 because it is steady state condition. And by substituting the value into the equation, we can get the exit temperature, which is 589.5 meter per second.
And for part C, the question asks for the exit area of the nozzle. So to find the exit area, it will be calculated from the mass flow rate. The formula that we use to calculate it is mass flow rate times exit specific volume divided by the exit velocity. Then the final answer that we get is 8.7 times 10 minus 4 meters square. And that's all from my group. Thank you.